Hi everyone! In today's video lesson, we are going to be talking about Chapter 5 of the Starting Out with App Inventor for Android Textbook by Tony Gaddis and Rebecca Halsey. This chapter is mainly focusing on repetition blocks, times, and dates. Repetition blocks include loops that repeat until they are stopped because of the conditions that are set. The notifier component is also considered a repetition block, and its function is to display a message and allow the user to either enter an input or choose one option. The clock component's function is to obtain the date and time from a device's internal storage, and the date picker's function is that it allows the user to select a date of their own choice. This was a little overview of the whole chapter. To find out more things about these components, keep watching the video. So firstly, we will be talking about the notifier component, which is included as one of the repetition blocks. So the notifier component is a non-visible component that is found in the user interface section of the palette, and the notifier block is found in the My Blocks editor section in the notifier 1 drawer. This component allows an app to display a dialog box after the user runs a code. So let's say that you have a code and you add a notifier to that code. This will allow you to display a dialog box on the emulator screen, which is visible to the user. So now you must be wondering what a dialog box is and what its functions are. A dialog box is a box that can display a message or tell the user to input something in the dialog box. The notifier component can display three main types of dialog boxes. These include the message dialog, the text dialog, and the choose dialog. So let's talk about what the message dialog is and what its functions are. The message dialog displays a title and a message, and it waits for the user to click a button. When the user clicks the button, the dialog box closes, and this is how the message dialog simply works. This message dialog is located in the My Blocks editor section in the Notifier 1 drawer, and it is called the Show Message Dialog method. This method contains three arguments. The first one is message. This argument contains the text of the message that needs to be displayed, and this is shown on the image on the right, where in the message socket it says something happened, but instead of that you can write anything you would like. The next argument is the title. This displays the title on the dialog box. So in the example on the right, the title is important message. And the last argument is the button text argument, which displays the text on the dialog box's button. And in the image on the right, the button text is okay, but you can write whatever you would like. And if on the screen, you can see that there's a small box on the bottom right corner. This is the dialog box that is shown to the user when they get the message. The second most commonly used method is the text dialog method. This method displays a message and provides a box in which the user can enter an input and then waits for the user to click a button so that the after text event can take place. Two events occur during this method. The first one is the button text dialog. This event displays a message and provides a box for the user to type an input, and it is found in the button 1 drawer in the blocks editor section. And as you can see on the screen that the first image is the button text dialog. So the button text dialog has three arguments. The first one is message. This argument displays the text of the message, just like the one shown in the example. The second argument is the title argument. This displays the title of the dialog box. And the last argument is the cancelable argument. This tells you if something has a true or false value. If the argument is true, then the dialog box will have a cancel button, and if the argument is false, then the argument will only have an OK button. Just like in the example, it shows us that the argument is true, so this means that there will be a cancel button and an OK button. Now let's move on to the second event of this method. The second event of this method is the after text input event. This helps retrieve the input entered by the user after the user clicks the cancel or OK button, and this is found in the Notifier 1 drawer in the blocks editor, and an example of this is the image on the bottom left of the screen. This event holds one argument, which is the response parameter. This parameter helps retrieve the user's entered input and displays it on the screen as an output text. And just note that if the user clicks the cancel button, then the response parameter will only display the text cancel since the user didn't input anything. The third type of dialog box is the choose dialog. This is a dialog box that gives the user a choice by giving them two button options and optionally a cancel button. And you can also decide what text you want to put in those two buttons. For example, you can put a yes and no or a chocolate and vanilla button. For this method, when the app runs, the user clicks a button and the choose dialog appears, which gives them two or three button options. Then, the app waits for the user to click button 1, button 2, or the cancel button, and then the after choosing event takes place. This method has two events. The first one is the show choose dialog event, which takes 5 arguments and is located in the notify1 drawer. The first one is message. This displays the text of the message. The second argument is title, which displays the title on the dialog box, and the third one is button text 1, which displays the text of the first button. The fourth argument is button text 2, which displays the text on the second button, and the fifth argument is cancelable. This argument is determined after looking at if the argument is true or false. If the argument is true, then there will be a cancel button with two other buttons. And an example of the button choose dialog is the first image on this screen. The second event is the after choosing event. This is found in the notify1 drawer in the My Blocks editor section. This event holds one argument, which is the choice parameter, and this holds the text of the button that the user clicked and displays it on the emulator's screen, like shown on the image on the bottom right corner. This emulator's title is confirmed. Its message is do you want to continue? And the choice given is a yes, no, and cancel button. And this is how the choose dialog's emulator usually looks like. An example of this dialog would be that if the user clicked the no button, then the after choosing event would display a no. Now let's move on to the while loop. Programming languages provide special tools known as loops that repeat operations as many times as necessary, and the while loop is one of those. The main purpose of the while loop is to repeat a set of statements as long as a Boolean expression is true, and it is found in the control drawer of the My Blocks editor section. This loop gets its name from the way it works. So this loop has two parts. The first part is a Boolean expression that gets tested for a true or false value. The second part is a statement or a set of statements that are repeated as long as the Boolean expression is true. The while loop block has two sockets that perform operations. These two sockets are the test socket and the do socket, as shown in the image on the right. The test socket holds a Boolean expression, and when the loop executes, the Boolean expression is tested. If the Boolean expression is true, then the blocks in the do socket can be executed and the loop repeats itself. If the Boolean expression is false, then the while loop has to end, because a while loop only works if a Boolean expression is true. Also, every time the loop repeats itself, it is known as iteration, and we say that the loop is iterating. The while loop is also known as the pretest loop. The pretest loop means that the loop tests its conditions before iterating. The loop does this so that it knows how many times the loop has to iterate and when the iteration is supposed to stop, depending on the condition that is set at the beginning of the loop. So for example, let's say that the condition that is put before the steps is if count is less than 5, then continue. So the loop would iterate 4 times, and when it goes to iterate the 5th time, the loop would stop since the condition is that the count has to be less than 5 to continue repeating. Another important thing is to keep appropriate initializations before the loop. This is so that you know that the loop will iterate at least once. For example, if I initialize my count variable to 6 and then keep a condition that if the count is less than 5, then continue, this loop wouldn't iterate since the condition says that the number has to be less than 5. And the counter variable is already initialized to a number greater than 5. But if the count variable was initialized to 0, then the loop would definitely work, and it would iterate. By now, you must have found out that the while loop will only iterate if the Boolean expression is true, and this is only possible if the loop contains relevant information. One of the most important parts of the while loop is the counter variable. The counter variable keeps count of how many times the loop iterates, and the counter number increases each time the loop iterates. So this variable is commonly used to control the number of times a loop iterates. The count variable is usually set to 0 and it increments by a number each time the loop iterates, and this is why the count variable is used as a counter. Another important thing to remember is that the loop will only execute if the count is according to the condition that is set at the beginning of the loop. Infinite loops are a part of the while loop function as well. If the iteration of a loop doesn't stop, it is referred to as an infinite loop. Usually, loops must bring an end to themselves by making the loop's Boolean expression false at one point. But if that doesn't happen, you would simply call it an infinite loop. Infinite loops usually occur when the loop has no code and it would repeat until the loop gets interrupted. In most cases, infinite loops should be avoided as they don't show any results. Another type of loop that we are going to be talking about is the for each loop. The main purpose of this loop is to initialize the first value of the loop, increase the counter variable every time the loop iterates to obtain a value, and to perform tests for problems that require a counter. This loop is appropriate for problems that require a counter because it is very useful when iterating a loop a certain amount of times. The for each loop block is found in the My Blocks editor section in the control drawer. So now let's take a look at the different parts of the for each loop that is shown below. So you see how number 1 is pointing towards the word number? This is the spot where you can name your loop variable. When you first get your for each loop block, it is named number by default, but when you click on it, you can change the number of the variable to whatever you would want. Then number 2 is pointing at the from socket. This is where you initialize the starting value of the variable. So when the loop starts executing, the variable would be initialized to the number you set it to. Number 3 is pointing towards the to socket, which specifies the variable's ending value, and you can enter any appropriate value in this socket. So this means that when the counter variable reaches this value, the loop would stop iterating. Number 4 is pointing towards the by socket, which specifies the amount added to the variable at the end of each iteration. The default value is 1, but you can change it to whatever you want. And number 5 is pointing towards the do socket, in which you can plug in all your blocks, and these blocks will execute each time your loop iterates. A very important part of the for each loop is calculating the running total. The running total is the sum of a set of numbers, and the running total is usually calculated in programs. The programs that calculate the sum of a set of numbers include two elements, which are the loop and the variable. The loop element reads each number in a set of numbers that are being added to the loop, and the variable element accumulates the total of the numbers as they are added to the loop. Also, the variable that is used to accumulate the total of all the numbers is called an accumulator. A value is added to the accumulator every time the loop reads it, and it is best if the accumulator variable is initialized to 0, because if it is a value other than 0, then the accumulator will not give the correct total when the loop ends. To understand the for each loop component, we will be making an app that includes the for each loop. So today we're going to be making an app called Sum of Numbers, and in this app, we will be using the for each loop to calculate the sum of a set of consecutive numbers. The set of numbers will always start at 1, but the user can decide what the limit of the set of numbers is. So for example, if the limit for the numbers is 3, then the program will sum up all the numbers between 1 and 3, so it would go like 1 plus 2 plus 3, and then the sum of these numbers would be your final result. So we will start by starting a new project, and we will name it Sum of Numbers. And remember, the title can't include a space or it's not going to work. And this will lead you on to the designer page of the app. And there we go. First, design the screen of this app. So for this, we will need 2 labels, 2 text boxes, and 1 button. We will first add the label and change the name of the label by clicking on the table component and changing the name from the side. We will do this to the other text box as well, and we'll do this to the button and add a hint for the text box as well. So firstly, we will drag the label component from the palette of the user interface section onto the screen. Then we will drag the text box from the user interface as well, and then the button component, and we'll again drag the other label component, and then the other text box. So we will change the name of the label to upper line from the properties section. With a semicolon, and then we will change the hint of this text box to enter upper line. So enter upper line. And then we'll rename the text box. So to rename this, we'll go on the component section and press the rename button at the bottom, and we'll name it to text box upper line. And then we'll change the name of the button. So we'll click on the button component and rename it to calculate. Calculate. And then we'll change the name of the second label. So that label's name will be sum, with a semicolon as well. And then we'll change the hint of the second text box to total sum. And we'll rename this text box to text box sum. So this was the designer section. And for the button, we can actually rename the button on the screen as well by going on the properties section and renaming it to calculate as well. So this was the designer section of this app. Now we'll be moving on to the blocks editor section. The screen is finished. Click on the blocks button on the top right corner to enter the blocks editor section. So we'll enter the blocks editor section like this. And then now we will bring the button component onto the screen by clicking on the button, calculate button, and it will give us a bunch of options. We'll choose the first option and we'll bring it on the screen. So this is the event handler block, and a bunch of programs will be made inside this. So inside this event handler, we will initialize a local variable that is needed to calculate the sum. So we'll find this variable from the variable section on the blocks, and we'll drag this to the inside of the calculate event handler. We'll change the name of this local variable to total, and we'll initialize it to 0. We will need to initialize another variable, so we'll change the editor. In the editors section, we'll edit this variable and add another name. We'll change the other variable's name to upper line. And we'll initialize it to text box upper line. And we'll change the text background color to text. So this is what our blocks look like so far. And now let me tell you what each block's function is. The total variable acts as the accumulator, since the accumulator gathers the total of all the numbers and it is initialized to 0 so that the loop will calculate the accurate total. The upper limit variable will hold the limit of a set of numbers or the range of numbers, and this will be initialized to text box upper limit text, since this will consider the input entered in the upper limit text box by the user. Now we will add the for each loop, which is found in the control drawer, and we will name this loop as the counter variable, and we will initialize the from socket to 1 so that the counter variable starts at 1. So click on the control center and drag the for each loop inside the calculate event handler, and then we'll change the name of this variable to counter, and we'll initialize the from socket to 1. We will initialize the to socket to get upper line, since that would be the value the loop would end at. So we'll go to the variable section and we'll drag the get block, and we will set the total variable to add the value of the counter variable to the current total variable after each loop iteration. So first of all, we will bring the set block, and then we'll drag the addition block and get the two get blocks that we need for this method. And then we'll name the set block to the total. We'll get the total and then add the current count. Now that we have the code that we will use to program the app, we need to figure out a way to execute this app. For this, we will use the Textbox sum display component, which is located in the Textbox sum component, and then we will attach the get total block, which will allow the display text box to obtain the total of the series of numbers. So we'll click on the text box sum, and we'll get text box sum display, and we will change the background color to text, and we will get the current total. So go on the variables and get the total. Now to make sure that our app works properly, we will test it using the emulator on your Android phone. So first, we'll click on the connect button at the top of the screen and click the AL companion. This will show up a barcode, and you'll scan the barcode using the Android phone. So this is the QR code we're going to be using to run the app, and this is the Android device we're going to be using to scan the code. So first press the button scan QR code, and then this will scan the code automatically. When the code is done scanning, an emulator screen will pop up like this. So for the upper line text box, enter the value 100, and then press the button calculate. This will give us the sum 5050, so this tells us that our app was successful. Now let's move on to talking about the clock component. This component obtains the date and the time from the device's internal system and provides functions for working with the dates and times. And it also works as a timer that operates at specific time intervals. App Inventor's clock component is a non-visible component which is located in the sensors section of the designer palette. And as you can see in the image on the left, that the clock component is not on the screen, and this is because the clock component is a non-visible component, which is why it is located at the bottom of the screen. A very important thing you should know is that the clock component works with dates and times using a special value known as instant. Instant is a number that represents an instant in the date and time. So this basically means that when you use the instant function, you would get the date and time immediately. To get the date and time individually by the instant, you would have to use one of the blocks that are shown in the image on the right. The first block would format the plugged-in instant to display the time only. The second block would format the plugged-in instant to display the date only, and the third block would format the plugged-in instant to display both the date and the time. Did you know that the clock component has a timer function too? The timer function works when the timer-enabled property is set to true, and it performs operations as scheduled intervals. The intervals for the timer are determined by the timer interval property as shown in the image on the right, and the intervals are usually set to a value in milliseconds. Timer properties event handler allows you to add the code that you want to execute whenever the timer event occurs. The image on the left is the block you use to add your code. The clock component has another function which is called the now function. The now function returns the current date and time as an instant. The purple call now block below is the block that is used for this now function. The other clock component's functions include functions that let you add units of time to an instant to get an instant that will occur in the future. In the list of all the blocks that are shown in the image below, the first block returns an instant in time in the days after the given instant. The second block returns an instant in time in hours after the given instant. The third block returns an instant in the time in minutes. The fourth block returns an instant in time in the month. The fifth block returns an instant in time in the seconds after the given instant. The sixth block returns an instant in the weeks after the given instant. And the last block returns the instant in time in the years. To make this more simple, let's take a look at an example. So when the user runs the app, their screen would display the current date and time, then the time 60 seconds from now, then the date and time 1 day from now, and then the date and time 6 months from now. These are the instants in time and date that can be made to get the future instant. If the user wants to find the future time only, then they would only use the time instant block. So these were the other few clock components that are essential in our daily lives. Now let's move on to the date picker component. The date picker component appears as a button on the app screen. When the user clicks the button, a display box appears, which allows the user to select a date. This component is found in the user interface section of the designer palette. For this function, the image on the left shows us what the emulator screen looks like before the user clicks the button, and the screen on the right shows us how the screen looks after the user clicks the button to select the date. The date picker component also contains an after date set event. This event occurs right after the user selects the date and clicks the set button. This event is used to retrieve the date that the user selected by creating an event handler for this, as shown in the first image below. This event is found in the Date Picker 1 drawer in the Blocks Editor section. The second image that you see on the screen shows you how the emulator looks throughout the whole method. The first screen is showing us what the emulator looks like before the user clicks a button. The second screen shows us what the emulator looks like after the user clicks a button to select a date. After the user selects a date and clicks the set button, the third image pops up, which allows the device to retrieve the selected date and display on the screen as an output. The date picker component is a very essential part of everyone's lives today. This is because it tells us the exact date. You must be aware that your device shows you the month, date, and year. But the question is, how does your device get the exact date? The date picker component gets the exact date because of its 4 essential properties. These properties are shown in the image on the right. The first block that is shown in the image is used to set the date picker component to display the last date that was set. The second block is used to show the number of the month. So if the number is 1, then that means that the month is January. If the number is 2, then that means that the month is February. The third block is used to show the month in text. So it would show up as January, February, March instead of the numbers. The last block is used to show the year that was last picked. Thank you so much for watching, and I hope you got a better understanding of the repetition blocks and the time and date components from this video.